Good afternoon, everybody. It's a privilege to welcome Dr. Chandra Swaroop Meena, Senior Scientist at the Architecture, Planning and Energy Efficiency Division of CSIR, that is Central Building Research Institute, Roorkee. Dr. Meena holds a PhD from IIT Roorkee and brings with him deep expertise in mechanical engineering with a focus on building engineering, efficiency, heat transfer, renewable energy systems, and thermal comfort. His research spans diverse areas, including solar energy, two-phase solar air conditioning using descent and heat pump water heating system. In addition to his role at CBRI, he also contributes to academic growth as an honorary assistant professor at the Academy of Scientific and Innovative Research. Dr. Mina's multidisciplinary work reflects a strong commitment to advancing sustainable and energy efficient building technology. Today, he will speak on the topic net zero buildings fundamentals to case study, offering us valuable insight into both theoretical foundation and real world application of energy natural building practices. Let us all extend a warm welcome to Dr. Chandan Swaroop Meena.
Thank you so much for nicely brief about experts of these sessions. Now I request Meena sir, so please start your sessions.
Thank you, sir. Thank you so much. Let me share my presentation. So shall I start the presentation? I hope it is visible.
Yes, sir, it is visible.
Okay. Thank you. Thank you. Thank you so much. As in my previous lecture, I have covered the fundamentals of net zero energy building and what is the possible approaches and the techniques we can use to improve building energy efficiency. So today I thought in continuation with the previous lecture, today I'm going to discuss the enhancing building energy efficiency through renewable energy integration. That is slightly, I have changed the title to make it more convenient or more relevant to the topic. So, and before starting the presentation, I am again very much thankful to Dr. Shubham Meena ji and the head of department and director NIT Patna for giving me this opportunity to discuss with you all. Okay, let's start with the presentation. Again, the similar to the previous presentation. This is the sequence of my presentation in which mainly the background challenges and problems, whatever people are facing while optimizing or designing different building prototype and building sector in the building sector. Further, I will be discussing the fundamentals of promising renewable energy technology that will be helping to achieve the net zero energy buildings and future R&D needs. Still, there is a huge scope in the research area. So let's start with the background of the topic. So as I have already discussed in the previous lecture, that is building in India consumed over 40% of total energy annually. Buildings are the second largest emitter of greenhouse gases after industrial sector. So clearly NITI Aayog also projected in their reports that 6 to 13 times by 2047, the electricity consumption will increase. And at the same time, increased demand for thermal comfort results in exponential growth of air conditioner. So they have projected in various reports that at least 30% of air conditioning or other in the other related areas, to air conditioning, number of air conditioning conditioner will increase. The same thing NITI Aayog also depicted in their reports, that the 6 to 13 times of electricity consumption will increase because in the building sector, because of air conditioning and other major appliances. We are excluding in the industrial sector. In the industrial sector also, because of the heavy machinery and other things, and as well as the space conditioning, all will be contributing major in the energy consumption sector, the thermal comfort and other things. So this is the electricity generation in India. This is the current scenario. So one can see the data up to 2019. Only 8.97 percentage of electricity is being generated through renewable energy. So still we are not up to the mark. So we will have to work on this, and in order to make the sustainable future, or to achieve the net zero or net zero energy as well as net zero emission targets by 2047, like that. So this is again the energy efficient building initiatives. There is so much things worldwide or in India, government initiatives they have implemented, or there is so many reports are available. They are clearly giving the guidelines as well as the SOP kind of thing. So that may be implemented in the energy utilization pattern in buildings as well as in industrial sector. So the main target was to reduce demand by 50% till 2030 in building sector, so that building energy consumption demand will reduce by 2040 to approximately 16% of the total energy demand. So these are the like pictorial view, or like the data. And the approach definitely will be the renewable energy utilization, whether it is solar energy, geothermal, wind, hydro, or biomass. Evaporative cooling is also included in this. So the in architecture point of view, as well as the civil engineer and the HVAC engineers, so they have to come to they will have to work together, and they to obtain the better performance of the building sector. So that is definitely the sustainable. We have to take care of the CO2 emission and the to control global warming and reduce the dependency on the fossil fuel that is huge nowadays. So the reason of renewable energy technologies is by 1843, the concern of running out the coal promoted experiment using solar energy. So after that, from last few decades, the intensive research is going on to mitigate the energy crisis and the environmental aspects. So similarly, these are the sequence of energy consumption and how the government initiated the thing. One can see in 1970s, energy, due to energy crisis, so the commission for additional source of energy developed by DST during March 1981. In 1982, the new department was created in the Ministry of Energy, that is a Department of Non-Conventional Energy Source. DNES was the short form. After approximately 10 years later, the same DNES, that Department of Non-Conventional Energy Source, became the Ministry of Non-Conventional Energy Source, MNES. And in October 2006, the name was changed and replaced by Ministry of New and Renewable Energy. Nowadays, that is known as MNRE. So the government is working continuously in the sector to utilize or to optimize the renewable energy in the building sector. At the same time, in 2019, the Science Minister launched this India Cooling Action Plan, so in which they have also projected the energy demand and the forecast of energy. So this is miniared turn of refrigeration. So one can see this major sector. So of space cooling in the buildings. So why this is growing exponentially? Because of our tradition, because of our adaptation of the European kind of building structures. So where if we don't the maximum uses of glasses in the hot area or like that. So this forecast one can see by 2037 to 2038, the 74% increase as compared to the previous years. So only then in the other sector, one can see refrigerators and other this transport, air conditioning and cold chains. They are not very much changing with the year, but the forecast clearly says we have to take care about the thermal comforts inside the building. That only like achievable with the help of good architect designs and practices, and the better energy efficient appliances and the approaches. So this was the the objectives of the ICAP, the India Cooling Action Plan. I have extracted the main points from the this report. So reduce cooling demand uh, across sectors by 20% or 25% by 2030 to 2038. Reduce refrigerant demand by 25% or if possible up to 30%, and reduce cooling energy. So how it will be possible to reduce the cooling energy requirements by 25 to maximum target is up to 40%. So this is only this can be achieved after the scientific interventions, or one can say the better performance of the existing systems that we are using in our household or commercial spaces. And the and another point, major point is cooling and related area. And the thrust area of the research under national science and technology programs. So this will be the major points in the ICAP document, and this is the projection of the demand by equipments. So different kind of equipments whatever we are using to optimize the energy. These are the renewable energy related points. So in this presentation, mainly I am discussing about the solar energy part, geothermal, including the evaporative cooling. How the previously evaporative cooling was used in the traditional construction. So after moving from traditional methods to the latest technology, so somewhere we are improving the energy, and at the same time we are losing the thermal performance or thermal uh, aspect of the building. So that's why we are not feeling comfortable without fans and air conditioning or coolers. So based on the climatic zone and conditions, there is so many technology available. So renewable energy can be used in various applications. So there are so much renewable energy potential: bioenergy, hydropower, solar, wind, ocean, and geothermal. So geothermal nowadays people are using in heating and cooling application apart from electricity generation, because the constraint in geothermal is if we want to produce the electricity, then we have to go for like hot spring and kind of things, so that are limited. But direct application like heating and cooling can be done through GSHP, geothermal or ground source heat pump techniques. And other thing is solar. Solar is mainly utilized in solar photovoltaic to produce direct electricity, and solar thermal. This is heat-based solution, direct heat, uh, heating, the direct use of heat energy. So there are different approaches. So renewable energy can be used based on the location as well as the availability of renewable energy. So current R&D in CBRI, so we are working on this solar-driven this solid desiccant cooling system, indirect evaporative cooling system, geothermal space conditioning, and solar-assisted heat pump water heating system. So I will try to touch the, each and every aspect of the technologies, how one can use in the building application. So let's start with the solar energy. This is the basics of solar. Solar is a one big, or I must say, the very big battery that can be utilized for direct electricity generation as well as the solar thermal applications. And the cooling demand, this I have already discussed. This is the cooling demand. So by using the active or passive approaches, there are different mechanisms. So this is building physics. Yesterday in my lecture, I have covered the building physics part. Today I am going to cover the renewable energy part and the thermal energy part, and electrically activated different approaches in air conditioning things. So this is the psychometric chart. This is the in refrigeration and air conditioning course of bachelor's program or in masters. It is the main thing that student has to understand what is the psychometric chart, or how one can predict or define the comfort zone in this psychometric chart. So this is psychometric chart here. This is the drivable temperature, and other lines are showing this is the relative humidity line, and this zone is known as the comfort zone. In this area, if temperature and relative humidity combination uh, will fall in this zone, then only people will feel comfortable inside the uh, any space or in any building compound. So this entire zone is known as thermal comfort zone. So this thermal comfort zone, how one can achieve if the temperature of ambient is 40 degree and relative humidity is around 10% is RH. Then in this the temperature one can find out in this area like that, or hot and dry in this area. So how we can achieve the comfort zone inside that building. So there is a different approaches like evaporative cooling, and by using the solar energy or like other source of renewable energy to achieve the comfort conditions inside the building. So this is tropical summer index in SP41 that is written by CBRI scientists only. So previously it was developed, so that it has this some tropical summer index TSI. So this is the empirical relation, and in that the range of temperature and other thing is defined to express the thermal condition. This sustainable cooling techniques, as I have mentioned, let's start with the evaporative cooling, and after that I am going to discuss this geothermal part and thermal driven cooling system, and at the end solar assisted heat pump water heating system or solar PV driven cooling system I am going to discuss. So let's start with evaporative cooling. So this is the evaporative cooling cycle. So one can see from the this figure. This is the simple cycle how the evaporative cooling or this process is taking place. So based on the climatic zonation of India, so as we know this, there is different climate zone, like five major climate zones are available. So now researchers are working in this area to microzonation. So still there is a patches, or there is a location where this entire, one can see this entire region comes under hot sorry, hot and dry, but this patch you can see in between, that comes under cold climate, because of the hills or like the cold temperature of the location. So this entire India is divided into different climate zone: hot and dry, warm and humid, composite, temperate, and cold. So in this Jammu and Kashmir, Himachal and Uttarakhand upper hills, this is known as cold climate. So here the air conditioning is needed in terms of heating the space and water heating. But at the same time in Rajasthan, this is hot and dry. This is hot and dry. Uh, uh, this is hot and dry. Here majorly the AC, the air conditioners, and refrigeration is needed. So like that, based on the this climatic zonation of India, we need different approaches or different techniques to make our space comfortable, so that we can that also directly enhancing the performance of the working pattern. So here one can see this, and this patch is comes in cold climate, and this entire patch is warm and humid. This entire, so sudden change because of the altitude of the location. So these are the some previous architecture that has inbuilt, or at that time the architects or designers has included the evaporative cooling in that particular location, like in Jaipur, in Taj Mahal, Golden Temples. So they have used this evaporative cooling concept, so that the entire space may be comfortable during even extreme summer season. So like that, evaporative cooling, this is the basic concept, how evaporative cooling will take place on the leaf of the any plant. So the same pattern, it is making that surface slightly cooler as compared to the ambient temperature. At the same time, in matkas, or in now previously or nowadays, that MeitY cool is also very much famous from this Rajasthan or Gujarat area. So they are all, that is also the technology is depending on the evaporative cooling itself. So this is and now people are working in the area of cotton fabric. So this is FESEM image of cotton fabric, how they are affecting the temperature of the body or surface. So this is the like thin film evaporation, how this this kind of structure is affecting the temperature, how this evaporation and boiling will take place. So this fundamental, before going to design any system, if we one is if one is talking about the desert cooler, so desert cooler will not fit in the warm and humid climate, because that in warm and humid climate, the humidity ratio is very like in the higher side as compared to the hot and dry climate. In Rajasthan itself, this desert cooler will work, but apart from Rajasthan, in like in Chennai or similar cities, this kind of evaporative coolers are not suitable. So this is the principle how evaporative cooler or evaporative pads are working. So there is different approaches of evaporative cooling or coolers. One is direct evaporative cooling, indirect evaporative cooling. So based on the location and based on the requirement, the researchers are developing the same thing. So this is in direct evaporative cooling. So what is happening that moisture content will drastically improve. But at the same time, in psychometric chart, one can see from 1 to 2, the temperature from 30 to 20 is coming because of the direct evaporative cooling. But at the same time, one can see these are the relative humidity lines. So in this, the relative humidity will increase from suppose 40% RS to 90%. So if we will use same approach or this kind of evaporative coolers or desert cooler, in simple language one can say, so desert cooler is reducing the temperature, that is okay, but at the same time it is also increasing the relative humidity. So in Rajasthan it will work, but in warm and humid, this kind of setup will not work. So in that reason, air conditioners, those are not increasing the relative humidity, but they are energy intensive. So we have to design our system such a way so that that system or devices will not use much energy, but at the same time the thermal comfort zone or thermal comfort criteria will also be matched. These are the listed advantages and disadvantages, parts of the nature's cooling cycle, and does not need any special type of refrigerant. This is the advantage and disadvantage of evaporator coolers and oldest and well-proven cooling technology. Desert coolers work on the principle of evaporative cooling and does not require any compressor, cannot reduce the temperature below wet bulb temperature, not effective for warm and humid climatic zone. Coastal regions के लिए this is not suitable. Increase humidity to the air stream. So this is the some basic thing. So this is the psychometric chart I have already discussed. This here, this is the zone that is known as thermal comfort zone. Nowadays, there is two terms frequently coming, that is uh, thermal comfort and adaptive thermal comfort. What is the difference between thermal comfort and adaptive thermal comfort is based on the climatic zonation or zone. If in the area of cold climate, so people will think, okay, if temperature is in the range of 10 to 15 or 18, then it is okay. But at the same time, if we will discuss with the hot and dry climatic condition, then we will feel okay that if the temperature comes in the range of 26 or 28, then it is okay. So because of adaptiveness or because of the like behavior, so that is the main that is the main criteria. So that's why now the adaptive thermal comforts also came into the picture. So and another thing is indirect evaporative cooling and evaporator coolers. So this is the indirect evaporative cooling, and this is direct. So direct evaporative cooling used in the desert cooler. Indirect evaporator coolers one can see in the air conditioners or in specific applications where we don't want to increase the relative humidity only in that particular area. Indirect evaporator coolers is used, but their performance or energy consumption in this indirect evaporator cooler is slightly more. This is the example. So from 1 to 2 and 1 to 4, they are the different approaches. So in as I have already discussed in the previous slide, this is the difference between direct or indirect evaporative cooling. This is indirect evaporative cooling performance. So how it is affecting the performance of based on the tube length. So primary air steam temperature variation along with the length of primary channel. So one can see in the relative humidity pattern, if the length of primary channel is increasing, then after some time it is uh, creating this kind of difference in the inlet fluid and outlet fluid in this is or output or like the desired effect, whatever we are using in that. So this is the advantage of indirect evaporator cooling. So does not increase humidity inside the room, can reduce room temperature below bed wall temperature, highly energy efficient and low cost, and compressor less operation and eliminates transient in power supply. This is indirect evaporator cooling graph. This is dew point and evaporator cooler. Let's discuss now the geothermal cooling. So inside, what is the use of geothermal and how one can understand the basic of geothermal? Because one in simple language, one can understand if this is the ground level. So as well as if we are going inside the in the earth or like vertical drilling, if we will drill vertically in the ground, then after 10 meter of distance, the temperature became stable. The temperature comes in the range of 18 to 24 degree Celsius. This is applicable in entire world, whether it is cold climate or hot climate. So around 100 meter of depth, that one can say 70 meter to 100 meter, the ground temperature is stable. Whether ambient temperature is 40 degree or minus 40 degree, that does not depend upon the ambient temperature. So this is the like study. So they same graph. This graph is also showing the same thing. The depth below surface. If we will go than 6 meter depth, then the entire soil temperature become stable. So this is the different geothermal cooling pattern. So there is the different approaches. Somewhere if available, like nearby pond is available or some lake is available, so people are using the pond looped collector. Or if the ground is available, then the horizontal tubing is preferred. Somewhere the space is little less, than ground loop collector is being used, and this is the best method based on the location. So after 70 to 100 meter depth, this heat pump is exchanging heat from 17 to 100 meter depth below ground level. So in that in this location, the temperature almost is stable up to 18 to 24 degree Celsius. So even if ambient temperature, suppose in summer, outside temperature is suppose 45 degree, and here stable temperature is if it is coming around 24 maximum, if we are taking, then it is exchanging heat from this 24 or 18 degree Celsius, and it is rejecting the remaining, or like it is cooling the space. At the same time, if the temperature ambient in the cold climate, if the temperature is minus 10 degree, then it is exchanging heat from 24 degree or 18 degree. So then it is heating the space. So based on the climate zone and climate conditions, this kind of different techniques of geothermal energy utilization is preferred. Or in European country or in German country, they are very much concerned about the renewable energy utilization in building applications. They are using geothermal energy for space heating or direct application, or one can say this is the direct application of geothermal energy. So one such prototype we have designed in our institute, that was the same and on the same pattern. So this is a blower, this is borehole, and a U2 with this vertical drilling. So this is the graphical representation uh, or pictorial view. I have tried to make this thing. So this is experimental setup. So 20 centimeter dia with the 20-meter depth borehole with PVC casing, and fixing of thermocouples on the casing to measure the temperature of water and earth below water table. So this is the experimental test facility. So from this, this is the measured data. So how this entire system is working. So we found out that after like 6 meter or so, the temperature is stable. Whether it is outside temperature is above the 40 degree or below the 10 degree in Roorkee itself. So this is the length of heat exchanger. So 8.90% reduction in temperature. After that, it is slightly stable. So, but nowadays the current situation is approx 70-meter vertical depth. Then it became almost stable. So the one can see here around 8.6 meter. The temperature stable temperature is 27, and after that 20 meter one can see the 25 temperature is still further. In last 2 years we tried to drill around 70 meter depth. So yeah, in that particular depth the stable temperature is coming around 20 degree. So people are saying ki, okay, just if we will or some report or Iran based report is giving 18 to 24 degree stable temperature inside ground, irrespective with the location. So this twisted waffle design, or one can see the flow, this kind of different structure to enhance the heat transfer for better performance inside the room. So this is the same graph. This was the inferences or conclusions. A building integrated borehole heat exchanger has been designed and installed at this location, and COP was observed in the range of 7.5 to 15. Uh, 7.5 to 15. So based in the morning or in the afternoon, 15 COP is coming in the afternoon time. So this is the like geothermal part. So at the same time, thermal driven cooling system also in the CBRI research is going on. So there are different approaches, closed cycle, open cycle, which kind of material we should use, which kind of approach we should use. So this is the some basic we see vapor compression cycle. So there is nothing like this approach is like known as like this four major components is available, or like is needed. One is compressor, another is evaporator, expansion device, and condenser. So this vapor compression cycle is used in our refrigeration, air conditioners, and the heat pump. So as per the need, one can use the heat pump as well as the refrigeration. But the major difference in refrigeration and heat pump is the need of uh, whether we want to cool the space or heat the space or heat the substance. So this is the vapor compression cycle. At the same time, another approach also available, but that are not very much explored and to utilize in the household application, absorption cycle. This is known as gravity driven cycle also. So this is the basic principle of absorption chillers. So where if these kind of approaches are mainly used in industries, these are because of the cost parameters. This is adsorption cycle. So this is also industry-based solutions, and another is sensible and latent cooling loads. So sensible and in sensible heat transfer, there is no phase change, and in latent heat, the phase change occurs. So that's why, and the heat transfer rate in latent heat transfer is much more as compared to the sensible heat. So sensible heat and latent cooling load is differentiated, and the how one can calculate the heat gain through sensible as well as in latent. So that also can be checked through the need or the application, based on the application. And another thing is desiccant-based cooling or heating solutions. So what is desiccant? The first question is, desiccant is a material or chemical composition that is used for absorbing the moisture from the present air. So a desiccant has the property that it can absorb moisture content from the cold air, and at the same time it is releasing the absorbed moisture if the hot air is passed over the desiccant material. So it is working in both the way. If this is desiccant wheel, if cold air is coming, so after moving through this wheel, then cold air with less relative humidity, here RH is more. If at the same time, if hot air is coming, and it is then this desiccant is releasing the moisture, so it will regenerate. So this is the property. So it is being used to remove the moisture and reduce the humidity and improve the air quality. So this is nowadays also used in the industrial sectors. This is the working principle. I have discussed this hot reaction here. So usually it is divided into two part. In one part it was circulated hot air, and in another part incoming air. If incoming air is coming, so it is absorbing the moisture. At the same time, this hot air is coming to regenerate this wheel. So at the same time, it is absorbing the moisture and releasing the moisture in the same cycle. So it is regenerating in the same cycle. So this kind of approach also is being used. So this is one can see this is the partition in half wheel. Absorption of moisture is taking place, and in another half or lower half, the regeneration of desiccant wheel is taking place. So this is the basic cycle, how one can use the desiccant dehumidifier wheel for space conditioning. So let me explain this. This is the sun, or this is solar collector. The solar collector is absorbing the direct rays of solar radiation, and the hot water is coming, and it is going through the heat exchanger, as well as it is also going in the indirect evaporator coolers. And there is two wheels. One is heat recovery wheel, and another is desiccant dehumidifier wheel. So one can see that this is hot. Red is denoted as hot air. Hot air is making this wheel as a regenerative wheel. or another half portion is absorbing the, this is the flow. From this, it is absorbing the moisture from the coming air. So this is the basic diagram of desiccant cooling system. So, and these are the different pairs of desiccant materials. So researchers are using the different pairs and to reduce the regenerative temperature, because if the regenerative temperature is high, then the for regeneration we need high temperature, so the energy consumption is also high. So this is the different material combination. So usually people are using the silica gel based desiccant material. So the regenerative temperature is around 60 degree. So 60 degree can be easily achievable to regenerate the silica gel. And now come to the solar PV driven cooling systems. So at the same time, in the previous slide, this was the vapor compression cycle. And to drive this compressor, if we to drive this compressor, we need this entire setup or solar photovoltaic setup to make this system standalone. So after making this system standalone, it can be used in the remote location or where the electricity or grid supply is not available. So this is hybrid, because in this the grid supply is also denoted, and this setup is completely photovoltaic. So this is the hybrid setup to run the vapor compression cycle. So this kind of different approaches is being used to drive the air conditioning as well as the to make water heating or refrigeration cycles. So the COP comparison of different cycles, the vapor compression cooling, the COP is slightly less as compared to the evaporator coolers. So evaporator coolers is giving a good performance, and geothermal passive system is giving the best COP combination, because in this the ground temperature, the below ground, below around 70 to 100-meter depth, the ground temperature is stable, or the life of this ground temperature, stable ground temperature is around 50 years. So in 50 years, this does not require any additional source of energy to work, to give power to the heat pump. So this is this is the main reason the geothermal has the huge potential over the other solar or other renewable energy. But at the same time, if we are not able to drill this much of depth, then solar energy is giving the better performance to improve the energy utilization in the building. This is the some inferences, like alternative and attractive cooling technology to vapor compression cooling are available and should be integrated with future buildings. Integration of renewable energy for cooling is very attractive and sustainable option and should be explored. And return on investment of solar or renewable integration cooling system is approximately 2 to 5 years. Recently, we have developed one setup that's also showing the return on investment around 1.8 year. At the same time, evaporative coolers is the most sustainable, nature friendly cooling technology, and other integrates options such as IC or direct evaporative cooling should also be explored. The option of integrating the desiccant driven indirect evaporative cooler or direct evaporator cooler is also a very sustainable option in the area of warm and humid climatic zones. So this is the basic of like different approaches how people are working. So utilizing the solar energy or geothermal energy has the huge potential in the building sector. So let's discuss about the solar energy part or future research technologies, ki how one can work on the different cycles. These are the different cycles, or heat pump or thermo acoustic and thermoelastic, because by doing the or by using the single approach So one cannot achieve the potential, or one cannot extract the maximum efficiency from any system. So we need to, so one can see here, there is a people are now started using heat pump technology. To run this heat pump, they are using geothermal as well as the solar heat pump. So these are the applications of solar thermal collectors in buildings. Uh, this uh, this is the background that everyone knows the solar energy, how solar energy is falling on the Earth's surface, and what is the average parameters of solar energy, and what is the average range of solar energy falling on the ground. So in India, average solar radiation is 4 to 5 kilowatt hour per meter square per day annually, and as well as per day, this 4 to 5 kilowatt hour per day. So we have designed one setup that is working in the range of 3.5 to 4.5 kilowatt hour per day solar radiation, and that is giving the better performance. So the this is the some reference or some pictorial thing that some scientist has reported in their research articles. So this is the different locations, different potential, ki how people are using, how much of gigawatt of power generation is available. So these are the different terminology of solar energy, the irradiance and solar constant, sunshine hour, direct radiation, diffuse radiation, albedo radiation, global solar radiation. One can see with the help of this photograph. So if solar radiation is falling on the ground, and after that, if it is received on the flat plate collector or any other kind of collectors, it is known as albedo. And if the solar radiation is directly received by the flat plate collector, then it is known as direct radiation. And similarly, diffuse, if it is scattered and it is received through different mediums, or like in sky. This is the different angles, latitude, slope, and surface azimuth angle and angle of incident. So this is required to calculate the how much solar radiation is incident on the surface, and how we are using the useful heat gain. So after designing, or after the solar radiation, whatever is falling on the flat plate collector or any kind, any other collectors, thermal collectors. So this is the basic formulas. So this is a formula of solar constant. So this is the solar collector part, or one can see the cross sectional view of this. So basically, it has the insulation part or outer casing. This is the tubes in which the working fluid is flowing, and it is the absorber plate. Absorber plate usually people are taking with the matte black paint or high absorbability paint. And another thing is glaze. So based on the location and the application, different number of glazing also varies. So the major research or major R&D area is to design the tube, and to optimize the heat transfer rate through the tube and working fluid. So this is the major area of research. Nowadays, people are working in this area. So in this, the fundamental research that is going on, that is the if the fluid is flowing inside this tube, then how this tube surface or tube can enhance the heat transfer rate, so that the maximum heat transfer can take place from the surface to the working fluid. So this is the major research, because this flat plate collector is developed way back, many, like I think few decades back. But now people are working to improve the efficiency of this kind of collectors, solar collectors. So these are the major component, that is absorber plate, collector, or glass or glazing, housing, or one can say the frame and the piping. This is the process of flat plate collector, how it is absorbing. In the previous lecture, I have discussed about the glass effect on the flat plate collector, because it has the property that it only allow the short wavelength of the solar radiation, and it after absorption that heat through in the tubes and other plates, it does not allow to leave the long wavelength solar radiations. So this is the performance analysis. This I've discussed in my previous lecture also. This is the useful heat gain formula. To that only I was discussing in the previous slide, the how much energy is being utilized efficiently to make or to heat the water, as well as to improve the system performance. So this is the major thing, that if we are able to improve the useful heat gain, then we can say the thermal performance of any system is increased. So this is quantifiable thing. So one should work on this area, and this is the potential area where the people are working, and there is still a scope to work in this area. So this is FR is the collector efficiency factor. This is empirical relation. So this is the formula of evaluating the efficiency of collector. So in efficiency of collector, this Q useful is the main factor, because this solar radiation, incident solar radiation, we cannot control the incident solar radiation, but if we are able to maximize this useful heat gain, then it may be the good option for mm, the system development. This is performance analysis or exergy and efficiency of collector. This is the attributes or affecting the performance of solar collector is the multiplying the glazing based on the location, transmissivity of the glass, because nowadays the companies are making the high transmissivity glass and anti-reflective coatings. So still there are so many coatings are available, or CSIR itself is developing few anti-reflective coatings, so that the Q useful is Q useful can be increased, or this high absorptivity of the absorber plate turbulators. These are the different applications where we can use the passive thermal systems. This passive design or uses thermal convection of circulating heat in the water system. So the same thing I have discussed in the solar assisted heat pump water heating system. If we are able to optimize the evaporator part as well as the condenser part, then the heat energy can be properly utilized and transferred from evaporator to condenser in the refrigeration system, or in heat pump system. If evaporator can extract the maximum heat from the lower temperature, and it can efficiently transfer that heat to the condenser, then it is good for heat pump systems. This is the basic passive thermal system that is available in north zone of India. But this kind of system is not suitable for high altitude region of India. So for that particular reason, uh, we have to design the different kind of system so that it can be utilized in the cold climatic zone of India. This is the basic active thermal system. This kind of system is useful in the cold region of India, where the two-way or like two different loops are available. Yeah, this is one loop, and sometime this entire condenser is used as a storage tank. So it can be used as the second loop. So two loop system is known as active thermal system. This is the pictorial view how one can use the solar energy to make hot water in the geyser or the replacement of geyser, electric geysers. These are the different solar thermal collectors classification, the non-tracking or tracking collectors. So this kind of collectors is being used in different applications. So flat plate collector is used to heat the water up to 75 degree Celsius. That is for domestic purpose. One can use in the kitchen, washrooms, and the other applications, or dishwashing and other applications. So this is flat plate collector, does not need any tracking system. So, and other the similar yeah, etc also is being used in the domestic as well as in commercial spaces. There are different solar thermal collectors are available based on the application or and uses people are using. So this is the working temperature range as well as the efficiency of collectors. People are working to improve the efficiency of flat plate collector nowadays, because this does not require any tracking. So that's why this is very easy to install and low maintenance. etc what is the main major problem in etc? etc will break if a small thing, if something fall on the etc or due to the heavy wind. So evaporative tube type collector will get damaged. The performance curve, this is the performance curve, how the evacuated tube type collector and other glaze or unglaze collectors giving the performance. And this is also the performance curve. This is a different applications. So for, if particularly for water heating application, so different vacuum type of collectors are used. So that can go up to 350 degree temperature because of the vacuum, because in the vacuum the it will act as a insulation material, the insulation. And the etc tube also being used for water heating applications. In that also, because of the these copper heat pipes and non-toxic liquids, and the it can work in the temperature range up to 10 degree or 5 degree, but below freezing temperature, it will not work in the cold climate. It is very much suitable for Rajasthan as well as in MP, Gujarat, or in hot and dry climate. This is the heat pipe in evacuated tube type collector. This is also being used. And compound parabolic collector is also used in the solar cookers uh, to minimize the energy consumption in the household or kitchen applications. This is PVT collector. So this is the combination of solar thermal as well as solar photovoltaic. So it at the same time it can give the hot water or produce electricity. So dual purpose it is solving. So this is also one technique to improve the or to reduce the electricity consumption in the household. This is parabolic trough collector. This is used for heating the water, or in somewhere in Gujarat, the people are using to iron the clothes. This kind of collectors. So because of this the concentrated principle, so it will give the hot water or hot steam up to 300 degree. So for space heating, this kind of system also being used. Its solar gain is also high. So people are using glasses that will act as a Tomway wall, because Tomway wall, the glass has a property to only allow the short wavelength. So that on it allows the short wavelength to penetrate the glass, and after absorbing the short wavelength, it will convert into the long wavelength. Then the same glass will not allow the long wavelength to go outside. So that will make house slightly hot as compared to the other. This is the passive approach. Yeah, this indirect solar heating. This is indirect means there is two loop. One loop is heating loop, another loop known as the heat exchanger loop. This is indirect solar heating, radiant heating. So people are using some kind of plate and tube arrangement. So they are flowing hot water or cold fluid or hot fluid. Nowadays people are using this um, this glycol based solutions, so that will not freeze in the winter. If the temperature fall below 0 degree, then the working fluid, if we will use water as a working fluid in this, if the ambient temperature goes below 0 degree, then the entire pipes will get freeze. So that's why the glycol based solution they are using in radiant heating or floor heating or floor or roof heating. So this approach also people are using. And solar window for cold climate. That's a similar. This is perforated GI sheet. So it absorb the heat. This solar window. This is the different approaches people are using from last few decades. So still they are improving the or they are working to improve the efficiency of different approaches. This is the AI sheet pattern, how the AI sheet is heating the indoor spaces. The same solar energy is also being used for cooling the environment. So this is vapor absorption cycle. This is not that much popular, but this is gravity driven cycle. For drying, the solar air heaters are also used for grain drying and drying and the this other drying applications in the kitchens, and the it is very useful for farmers. So this drying is the nothing but a removal of water from the any food grains or other things. So this is the experimental test facility, or one can see this. This is simple structure is useful for grain drying. In cooking also, previously solar cookers was developed by CBRI itself, and further low-cost solar cookers that was placed in the affordable house of CBRI. So the still now now in CBRI the people are trying to develop the solar kitchen, entire solar kitchen with refrigerator, with hot water geyser and other induction or other this solar cooker integrations. So for ventilation itself, as this is known as Trombe wall. This is the basic concept of Trombe wall. If the cold air is coming, then hot air will go out due to the density difference or natural ventilation. So it is maximum people will find out this kind of structure in the Leh Ladakh region. In Leh Ladakh, every office and even in household, people are using this kind of structure to make their house comfortable. For distillation, the solar radiation heat up the contaminated water and allow the water to evaporate and leave the contaminated behind. So this is also the desiccant based approach. So in this, as I have already discussed, the desiccant. What is desiccant? Desiccant can absorb the moisture from the cold air, and it will release the moisture if the solar radiation fall or heated air is circulating over it. So that can be collected. So this a brackish water, though due to evaporation, it will stick like that, and due to the slope, it can be collected uh, from the another end. So this is the distillation process also done. So if we are able to uh, reduce the energy consumption, then definitely we will go towards the energy efficiency or net zero energy target. So for definitely for power generation. So there is different approaches. This kind of high efficiency collectors are being used for power generation. This is also the central tower receivers, so that it can be used for high power generation plants. And it can, solar energy can also be used in the solar chimney and other applications, wind turbines and generators. Heating demand in high altitude regions. At the same time, we are talking about the cooling. In the high altitude region, heating is also playing the major role, because in high altitude region, people will not think about the cooling the space or cooling the water. In high altitude region, you will not get like single refrigerator, single AC, or they are not using air conditioner in their house. They In every household you will get the bukari to heat the water or heat the space, and the this bukari as well as the geyser you will find out in the washroom, in the toilet, in the kitchen, in fact somewhere you will find out in the open spaces, because they need every time hot water as well as hot air, matlab, space heating. So these are the some challenges the people are facing. This is the major challenges one can see in this picture. Leh around 35 uh, 35 meter from the ground. Sorry, 35 meter from the ground level. 3500 meter from the above the sea level. Sorry. What is the this picture is showing the 65 percentage of oxygen molecules per breath of that at sea level. What is the meaning of this in the north area in MP or in Delhi? If one person is breathing, then it will he will get if 100% of oxygen, and at the same time in Leh or Ladakh region, it will get only 65% of oxygen as compared to the plain level. So there is very less oxygen content. So because of this less oxygen content, whatever diesel based solution they are using, that are also less efficient. So because of this less oxygen content, the incomplete combustion of fossil fuel poisonous for occupants. So this is the challenge, and temperature goes minus 30 to 20 degree year around, and low cost, low efficiency of the passive solar thermal water heating system. So because the working fluid is water, if the ambient temperature goes below 0 degree, then entire pipe will get freeze. So this is a major problem. Water freezing in toilets due to low temperature. So people are using insulation over the toilet pipes. So these are the challenges. The people are using this kind of heaters in the toilet itself. So this kind of matlab intensive energy they need to make space hotter. So this kind of major things you will find out in the high altitude region. So we propose one solution with the technical specification. The heat pump be completely modified and to utilize, and we improve the tube structure with the fundamental study of boiling heat transfer, so to extract so that it can extract the heat from the sub-zero temperature or minus temperature. This is the combination of solar passive approach as well as the active approach. So this is somewhat kind of like the modified heat pump system, we can say. So this is the setup, how we have modified and we have tested. So and this system or can be useful for the temperature range or solar radiation in the range of 3.5 to 4.5 kilowatt hour per meter square per day. So this NREL graph is showing this entire area of upper hills of Uttarakhand, Himachal Pradesh, as well as the entire Jammu Kashmir and Leh Ladakh region, and northeast region is falling in the range of above 4.5 to 6 kilowatt hour per meter square per day area. This 4.5 to 5, this entire yellow color area. So we designed the setup. We also see the solar radiation pattern and temperature compared with Ladakh in Roorkee, in Leh, and in Pauri Garhwal. So the solar radiation and the ambient temperature we also compared in the month of May after this April or till October. The solar in the solar radiation pattern is more short wavelength. Short wavelength of solar radiation is more as compared to the Roorkee itself. So because Roorkee comes in the composite climate and Leh comes in the cold climate, so we thought ki if we are able to design one setup so that it can extract, it can trap and it can use the short wavelength, then that will be useful for the people of high altitude region. So this is the comparison of different average high and low temperature hours of daylight of Roorkee, Pauri Garhwal as well as the Leh Ladakh. So this is the potential of development, how the system, the electric geyser and solar heat pump, the energy consumption pattern with the same capacity. Return on investment also we calculated if people are leaving the or we remove their electric geysers, then it has the huge potential. One system we have installed in the Kalpa Kinnaur. This mountain is Kinnar Kailash. This is Kailash Parvat. It is very much near to the Kalpa village of Himachal Pradesh. So we successfully installed this kind of improved setup, and the people are using this system. This is the different connections one can see. So this is another thing. This is like another part. This is the video. Please see. This is the entire journey from development of setup. From Roorkee, that is 900 feet to approximately 12,000 feet. This is very easy to install setup. सर यूज करिए, ठीक है।
जैसे नॉर्मल
आप हाथ लगा पा रहे हैं, कंटिन्यू 2 मिनट हाथ लगा पा रहे हैं आप?
बहुत ज्यादा गर्म है,
चालू करके देखो।
So this is the like setup we have installed in the Kalpa as well as in the army barrack. So this system well suitable for the solar radiation in between 3 to 5 kilowatt hour per meter square per day, and this reason is also falling in this same solar radiation thing. That one international report clearly showing the solar water heating program or heat pump technology that has the potential for improved heat pump technology that has potential to cater the hot water demand in the high altitude region. The system also we have designed and installed in our campus. So from last more than 1 year, our entire canteen is running on this setup. So this is one animation. I'm trying to show you how we have designed, how we have installed, how we are checking the performance of our system. So this is the similar department, or we have tried to animate this. This kind of, this is just a solar thermal collector. This is photovoltaic. It is running on the entire photovoltaic setup. Or this is standalone. To check this entire system, we have tried to make the prototype and to check whether it is working in the peak winter in composite climate, or how this will be useful. So this is a solar thermal collector. So this is entire piping arrangement, how we have compared with the existing electric geysers. So if we have also placed the electric geyser beside this, and this is our solar water geyser, solar hot water geyser. So we are also, we are at the same time we are measuring the energy consumption of the electric geyser. At the same time, we are seeing the performance of our solar geyser. This is the entire control panel, and how this is the placement of different data logger and computers and power control units of photovoltaic setup. In this photo, we are not doing research on the photovoltaic part. We are mainly concentrating on the solar thermal setups. So this is the entire um, placement of connections, and how this is this power control unit, solar inverter, one can say. So this is the lab. So this is the results. In the extreme peak winters, the system is performing well, and it is consuming approximately 8 to 10 times less energy as compared to the electric geysers. So this is the target. This is the target ki how we want to replace high altitude region. So this is the conclusion of the entire presentation. To achieve the net zero energy buildings, we have to go for renewable energy technologies in the future, or because till date we are only producing the electricity approximately 8 to 12% of the total energy demand of India. So we have to increase the percentage use, and there is an urgent need for transition from oil-based energy system to renewable energy systems. So this kind of or renewable energy system does not only require the money or like the monetary things. It has the potential to create the employment opportunity at all levels, especially at rural level. So this is the conclusion. Thank you so much. Thank you. Now, if anyone has the any question or suggestion, please ask.
Yeah, thank you, sir. And the participants, if you have any query, so please ask the experts. If any one of you want to discuss your research area, any problem, and platform is open for you. You can discuss with the experts.
Sir, I want to have a question about the geothermal cooling part.
Yes, please. Yes, please.
Can you show please your experimental setup? Experimental setup for geothermal cooling. I have one doubt regarding the blower placing. Generally in air conditioners, like VCR or whatever type of air conditioners, we shuck the hot air from the ceiling part.
Actually, the thing is, sir, uh, the pictorial view I have showed, that was the basic thing. Recently, we have designed and developed the net zero energy building in our campus, in which what we have done, 70 meters depth vertical drilling. We have done 5 boreholes. So let me show you the actual. Actually, because of the like some confidential things are going in our department, so that's why I have not shown the actual pictorial view of the geothermal. That was the conceptual part, ki how one can utilize the geothermal energy. So okay, if you want, then I can show you the actual geothermal photographs ki how we have done.
No, my doubt is only that the blower section should be from the top, not from the ground part.
That blower, that
As I saw in your diagram.
Yes, yes. That's why I'm telling. There is two kind of approach. One is air circulation, another is fluid circulation. For air circulation, you have to place or blower at the ground only. Another, if you are using the glycol based solution, then only the FCU unit will be placed on the roof or like on the ceiling or on the top part. As you are correct, you are mentioning absolutely correct point. But that whatever photograph I have shown, that was the air circulation. Matlab we are exchanging heat through air.
No, yeah,
Rece-
that's okay.
uh, uh,
Let it be the air part. What
uh,
I am looking, I saw in your diagram that the air was circulated from the ground, or air was sucked by the blower to feed
it,
in the your ground pipe.
uh,
And let me complete, please.
uh,
That was from the ground part.
mhm,
As I understand, because the air density, hot air
mhm.
density is lesser than the colder air density. So that's why in every VCR system or whatever type of AC system, we shuck hot air from the upper part or from the ceiling part, not from the ground part, because cold air, due to the density difference, it comes down from the top to down or from ceiling to ground part, as I understand, or whatever may be the your reason or whatever will be the clarification about that one.
Yes, sir. Let me explain. That blower you have seen in this photo, that was to extract the air or to suck the air from the ground source heat exchanger. In the room itself, there was another FCU unit that was circulating from the top only. So that photo itself is showing from the ground circulation. Oh, you are right. In inside room photograph is not available. So inside room from the top only it is circulating the air.
Okay, so you measured all data circulating air from the ceiling part,
Yes,
not
yes.
from the ground part. Okay.
That was for only sucking the air from the ground tubes only.
No, ground you. And the second question is how you make coils at the depth of 70, 80 meters to enhance the
Because
heat exchange, or to make a heat exchanger or enhance the heat transfer coefficient, heat
actually,
transfer.
yes, sir. Actually, we are using SDPA tubes to exchange the heat. Though in the grouting, इन द ग्राउटिंग मतलब वर्टिकल ड्रेन जो जो हम लोग वर्टिकल बोर होल करते हैं वैसे ही 70 मीटर बोर होल करना है। उसके बाद में जो ट्यूब्स हैं उनको उसके अंदर एक बॉटम पे वेट लगा के अराउंड 50 kg का वेट लगा के उसमें फ्लूइड भर के उसको वेट बना के उसको 70 मीटर डेप्थ पे लेके जाते हैं सर।
नहीं
और
नहीं, दैट्स
उसकी
ओके,
हाँ
दैट्स
हाँ
ओके, वो ठीक है सर। मैं
हाँ
कह
हाँ
रहा हूँ आफ्टर ड्रिलिंग वर्टिकली हाउ यू मेड कॉइल फॉर्म में जो हीट एक्सचेंज दिखाया आपने, वो जो डिस्टेंस एट पर्टिकुलर डिस्टेंस से इट मे बी द 5 मीटर और 1 मीटर 2 मीटर, you make
हम्म।
coils and at the depth of horizontal coils, means in horizontal part, in drilling horizontally you shown the coils, how you made that one, that is the question.
Sir, please unmute yourself.
हेलो हेलो।
Yes sir, yes
हाँ
sir,
सर।
yes sir.
हाँ एक्चुअली सॉरी आई वाज लाइक म्यूट दैट टाइम। इसमें अभी जो कॉइल्स है ना सर, जो ऑलरेडी प्री फैब्रिकेटेड कॉइल्स आती हैं जो फ्रांस में और जर्मन बेस्ड कुछ कंपनीज हैं, उनमें हमें कॉइल बनाना नहीं पड़ता है। उसमें क्या होता है कि नीचे क्लिप लगती है जो उसको यू ट्यूब में करके और वो प्रॉपर एक ही ट्यूब में आता है सर। उसमें हमें अलग से कुछ भी फैब्रिकेशन या कॉइल बनाने का जरूरत नहीं पड़ता है। वो स्ट्रेट ट्यूब आएगा ऊपर। बाद में हम लोग क्या करते हैं, उसके जैसे 5 बोर होल किए, उनके इनलेट को एक साथ जोड़ देते हैं, आउटलेट को एक साथ जोड़ देते हैं। तो आउटर जो हमारा हीट एक्सचेंजर और हीट पंप के साथ जो कनेक्ट होता है दैट इज वन इनलेट और वन आउटलेट। मैं अभी आपको कैन यू गिव मी लाइक 1 or 2 minutes, आई विल शो यू सम एक्चुअल फोटोग्राफ्स so that can be it can be easily understandable. Let me give 1 or 2 minutes, sir, please. Hmm. Yeah. Meanwhile, if anyone has another any other question, please uh, let me know. I'll show you the actual photograph, sir.
Sir, one other question.
Ah, yes, sir.
Sir, in Leh Ladakh region, I thought it is in high altitude, so the solar radiation will be very less, sir.
Mm-hmm.
So how do we get solar
Solar
energy?
radiation is not less in that area. You will, if you will see the solar radiation pattern, because we are continuously measuring from last 1 year. So solar radiation, you will get the amount of solar radiation as compared to the, if you will take the example of Kinnaur district and Shimla district, you will get maximum solar radiation in Kinnaur district, not in Shimla. Kinnaur ambient temperature you can say that is less in Kinnaur district as compared to the Shimla, but solar radiation is more in Kinnaur or Lahore Spiti as compared to the Shimla. You will get, this is the like myth, or people think there is a less solar radiation, but that is not like that.
Sir, another doubt regarding this geothermal,
Hmm.
like another question.
Yes,
What
yes.
is the practical problems you've faced in maintaining that geothermal experiment in research institute?
We have one test facility we have developed in CBRI under DST project to make this net zero energy building, in which two kind of approach we have used. One is solar thermal and another is geothermal. So geothermal part, the major problem is initial cost. So people in domestic purpose, people will not use geothermal because of the initial like high investment is needed. So that was the major problem because initial cost in air conditioners is very less. But if you will see the installation of geothermal part is huge. So for commercial application, it is viable because in Make in India, you will not get any better solution for geothermal GSHP ground source heat pump. So the indigenous part is missing. That's why the initial cost is high, sir.
So because of that much depth, like 70 meters or 100 meters, how do you maintain those pipes in that depth? Any like cleaning?
One time drilling is needed. After that, you can make the.
Hello? Sorry, you're not audible.
Hello. Hello.
Yes, sir. Yes.
Yes, sir.
Am I
Now you
audible?
are audible. Now you are
Yes,
Yes,
audible,
sir.
sir.
yes. So initial cost or that once you have drilled vertically, then after that you can make even garden over it. So that does not require any maintenance because you will make a trench over the surface and you will make a drill. After that, you will just fill that trench and you can use as the simple ground. So that is not required any further like any kind of this maintenance. I will show you the one poster I have made.
And that drill is made of just like borewell drill or anything.
Borewell drill only. Borewell drill only.
Okay.
I'll show you one. Same. Actually, I have made one good like one slide, single slide of the geothermal part that can be clarified in a better manner. Yes, if any other question, please.
Participants, if you have any query, please ask the experts.
Yes, I got that photographs. Uh, uh, can I share my screen?
Yes, sir.
Yes. Uh, is it visible?
Yes, sir.
This kind of drill. I think that sir is available or
Yes, sir. Yes, sir. I'm available.
this kind of drilling only is required. This is the connections. This trench and that control panel is inside matlab, like around 6 feet in the depth. It will be covered entire like after that this kind of trenches. So after that we will fill this entire trenches. This is the inlet and outlet. Sorry. I think now it is more clear.
No, no, it's okay, sir. But it's up
Uh,
to the depth of 6 meter. No?
no, this is up to 6 feet. This control
Okay,
part is up
okay.
to 6 feet. The depth is up to 70 meter.
No heat exchanger, the twisted heat exchanger.
This is only no. That is the basic thing, sir. This is actual photograph. That was the pictorial view. Ki
I
how
got,
we have
I got,
changed.
I got, sir.
So
I got here.
that was up to 8 meter. Oh, that
Hmm.
was the trial. This is the actual geothermal. This is
It's
the
a
actual
nice.
geothermal. That was we tried up to 6 to 8 meter itself. This is the actual geothermal part. So like final thing is available. This is the
This,
actual.
this geothermal concept is a nice one, but
Uh-huh.
and its life is, as you said, up to the 50 years it will survive. But what
Yes.
about the cost, initial investment?
Initial cost is huge, sir.
Yeah.
Sir,
Initial
all,
investment.
all these pipes and equipment is made in India only, sir?
No. This like double tube and single tube is available. Double tube is exported from abroad.
Okay,
As said,
thank
So
you.
sir,
make in India aspect is missing in this. So, but that system is working fine. That is the good part of this. It is running throughout the year. That system is, I think, much more competent as compared to the other available renewable energy based systems.
Sir, one question regarding this solar radiation part.
Yes, yes.
In Rajasthan, Gujarat, and Leh Ladakh part, the solar radiations are more in comparison to the other parts of India. How it happens? Because solar sun radiations are coming everywhere, I think equally. But how they are concentrated in Rajasthan, Gujarat part, and some Maharashtra part? As I was at Bombay, IIT Bombay, I also conducted experiments in solar part, PhD in solar itself. So how it varies from place to place?
Sir, initially I have shown the solar radiation calculations and how it is affecting based on the longitude and latitude. So because of that, the solar radiation value is varying from Rajasthan to Leh Ladakh. Initially, I have shown the mathematical part in that based on that, that was used for calculating the solar radiation, incident solar radiation part.
Okay.
Yeah, any other participants, if you have any query? So thank you participants for your actively participating in the question answer session. And now we move the session. So on the behalf of the organizing club team and all participants of the faculty development program in smart building design towards the net zero, we extend our sincere thanks and appreciation for your highly informative and engaging session, sir. And the case study and practical sessions and the application of renewable energy with the focus of solar energy was truly enlightening. And the way you connected theoretical foundations with the real world examples offers the participants a deep understanding of how renewable energy technology, especially solar, can be effectively integrated into the building systems and to move towards the net zero energy goals. So your clear explanations, practical insights, and the structured workthrough in the case study provided a strong foundations for participants to thinking critically and apply these concepts in their own academic and professional practice. So we are grateful for your valuable contribution to this FDP and look forward to learning more from you in future engagement. So thank you, sir, for your sessions and your time. And thank you all the participants for actively participations.
Thank you so much.
And
Dr.
with this,
Shubhamji.
now
Thank
we
you.
close the meeting. And
Thank you.
yes, sir.
May I leave now, sir?
Hello.
Thank you.
Yes, sir. Yes, sir. Yes, sir. Now,
Thank you.
now we leave. End the meeting.